Just a little farther.
It depends on the movie, so if it was a movie that I would have to really pay more attention to, then I probably would just watch that and not do other things. But if I was watching like a comedy, I probably would do other things and it wouldn't really bother me.
Sometimes I'll have the TV on and be doing something in the kitchen, which is right next to the living room. But most of the time I am sitting in the living room watching a movie. I may know something that's going on that night, definitely sit down and watch it.
No. If it's at home, I might be multitasking, probably multitasking, like texting while watching. But if it's at a theater, I'd probably go for like the experience.
Welcome back, everybody. I trust you had a healthy and hearty lunch break. Our next session is how you capture it. Will lightfield change the way of content production? I would like to introduce Dr. Siegfried Fossel, who is the head of the Department of Moving Picture Technologies at the Fraunhofer Institute. In addition to being a SMPTE Fellow, Siegfried is also a digital cinema pioneer whose work we benefit from at Pixar every single day, I can tell you that. So without further ado, I will turn it over to Siegfried.
Yeah, thank you very much, Cynthia. Yeah, ladies and gentlemen, I hope you enjoyed your lunch. This session is about lightfield, and I think many of you have already heard about lightfield. It's an exciting new technology, and we made a lot of progress in the last years. We have three experts from the industry here today to talk about the lightfield and what is the actual situation and what we can expect in the future. So we have here Al Lopez from Stargate Studios. He's the president of Stargate Studios. Jules Urbach, CEO of Otoy, and John Carafin, CEO of Lightfield Labs. But let's first start with a short introduction by themselves. So Al, please.
Hello, my name is Al Lopez. Yes, I'm president of Stargate Studios. We're a full-service visual effects company with 10 locations around the world.
Hi, Jules Urbach, CEO of Otoy. Otoy is a cloud rendering company. We're very focused on building out ecosystem and workflows that allow things like light fields, holographic, and volumetric video to be used practically today and to be published to the open web.
And I'm John Carafin. I think many of you know me from Lytro, from when we were here last year. And this year we're debuting the new company Lightfield Lab. And that company is completely focused on everything related to what happens after capture and on holographic display. So I'll be going into quite a bit of that for our presentation today.
Okay, thank you. We have a very tight schedule, so I will go fast through my slides, and all of the other speakers are really going fast through them, so keep your belts fastened. So the light field typically is all around you, so all of the light waves you have here in space forms the light field, and it's like an electromagnetic field, but in the visual area. And you can capture, of course, the light field by camera. But if you are using one camera, traditionally, you only have a very sparse sampling of the light field. You can do it better with more cameras. So you have this lenslet cameras, you have the camera arrays in different constellations. But the question here is really, can we have at the end a light field capturing that enables us the same processing like computer-generated images, and we want to address this in this session today. So to go to this light field processing, typically you capture the light waves from different cameras. You create some kind of 3D model, so you have some point clouds, you are creating some depth information, you have some bidirectional reflectance functions, you have some forward rendering to additional views, and that's what lightfield is going about. And then what you can do is, of course, you can do a lot of special effects like depth space color grading or the separating based on the depth information of different objects. You can also create point clouds. You can do relighting with this topic, so you can really create some kind of 3D objects and put 3D lights around of persons, for example, and relight the complete scene new. What you also can do, you can do some virtual camera movement. That means you can capture with static camera arrays, for example, and can do virtual camera movements without moving the cameras in reality. And this is really exciting because you can create more or less any viewport you want based on the light field. You can do a lot of applications with this, of course. You can capture objects, for example, based on light field technology, put them into a VR environment and combine CGI objects with real objects and have the same parallax and the same viewport like you have in a completely CGI environment. You can do also other things like refocusing. I think you all have seen in the past some of the examples what you can do without really moving your iris by only computation of the images. In the meantime, we have also some standardization activities. Some are in MPEG, like called MPEG-I, and here we have defined in the meantime 4 different ways for using the light field. One is the traditional 3 degrees of freedom with the 360-degree images, the 3 degree of freedom plus with some small movements so that you can move your head to the left and to the right. Some kind of windowed 6 degrees of freedom. This is like the classical light field approach, or a complete 6 degree of freedom where you can walk around in a scene with your VR glasses. And there is a first call for proposals on light field coding, and we have also a grand challenge on light field coding. And that's more or less all for this short introduction. I think it's more important to give all of the speakers some more time, and we run through all of these presentations, and at the end, of course, we will discuss it and give you also the opportunity to ask some questions. Okay, so thank you very much. So let's go to the next speaker. Al, maybe come on the stage and talk what you are thinking about light field.
Sure. Hi, so there's a clicker around here. Did you?
Oh, so thank you.
So yeah, feature cinema and how we capture. So as a visual effects studio, we are pretty much the end user of whatever technology people are creating, and we're very interested in light field technology, obviously, because a lot of what we do is the virtual, what we call a virtual backlot, which is something that we've been working on for over a decade, and that is really acquiring locations that allow you to come back into a green screen scenario and on set being able to bring the location to the actors rather than reverse of that. And one of the things there is, we've created this extensive library where we not only do we get to bring it to you, but basically we allow writers some options when there's budgets. A lot of the clients we have are television clients, so budgets and time are obviously part of that. And that saves some time and money. Production designers get to kind of know what we can bring to the table, and again talk about costs that you can save. But it's really about being able to offer a lot more and a lot more options as far as what you can shoot. And locations aren't strictly just a location like going to Hawaii or something. Part of the virtual backlot library is also being able to create environments, and we do that via 3D. And one of the tools we've been using in the past is to put it all together is a pre-visualization real time, which is we use Lightcraft. And what we've been doing is we've been being able to previs on set in real time, taking the actors, taking the assets, whether it is a 360 stitched environment or it is a full CG environment that we create. Another advantage of that is when you shoot on a full green screen stage, when you're trying to edit this thing together, you see nothing but green. It's really hard to edit something. So right off the bat, right off the camera, we get really decent comps for editorial. There's usually, large screens or VR headsets for the actors or for the director to be able to be part of that environment and see it completely blended together. And what's really important is because there is still post-production work, and that is being able to do get camera lens information, location, where it is in 3D space, what exactly the lens was doing at any particular time, and bringing that into our 3D software. So today, the way we capture it is traditional camera photography, some techniques that we've created, some rigs that we've invented, and to create these that are pretty efficient, allow us to template the work and bring it in quickly into our workflow. We also create 3D models using LiDAR scans and photogrammetry or blueprints or whichever way to be able to capture the 3D models and make them as photoreal as possible. And a lot of times when you're working with a pre-vision system, you're going to have to make that model real time. So we've created some procedures to be able to make them photoreal real time and work quickly when we're trying to do this in real time and on set. Future of the virtual backplot. So this is where we get to kind of ask, gentlemen on this panel, is that we would love to see in the future. And there's a huge process that goes along with how we capture all this. But what we really want is photoreal worlds in real time. The capturing process, how do we do this? You'll see, I'm going to try and pull up a demo here in a little bit, but you see a lot of green screen on a lot of sets when we talk about virtual backlot and virtual sets. And we'd really like to get rid of the green screen. We'd like to be able to not have to deal with all the issues that come with green screen that many of you probably are aware of. But we want to be able to capture the whole environment that we want to use. We want to be able to not have to spend a whole lot of time and energy processing it. And we want to be able to get it onto the set. And we also want it to be aware of each other. We want whatever we are capturing on set, whether the actors, if the DP is going to light to an actor, we want the virtual world to be able to be aware of that lighting in real time. The thing that if you want to ever see a shot go wrong, it's the lighting. If the lighting doesn't match between the actors and the real world, it's just a dead giveaway. So having lighting that matches real world in real time is going to be critical. And we hope and we think that lightfield technology will be able to allow us to capture a lot of that information and then manipulate it very quickly, as much as we can on set and obviously in the post-production process of visual effects. So, we're all in the business of storytelling, and this technology, we hope will support that for not only our clients, but also for ourselves, because we all like to create worlds and tell stories. So there might be a video after this. If not, we can get to it later. But what's that? Not ready yet. So what I think I'll do is, because I know time's short, we'll let Jules talk. All right, thank you.
Yeah, the next speaker is Jules. The next speaker is Jules Urbach, and now we want to hear, of course, a little bit more how we can go from a 2D image to a 3D space, and how we can work on this.
Great, thank you guys. Just at a show of hands, did you guys see the F8 announcement around the 6 DOF cameras that they're building and that we're working with them on? Okay, not that many people, so I will spend a little more time talking about that. So I want to discuss how we sort of look at the ecosystem that we're trying to help. A lot of, when people think about light fields and holographic and volumetric video, there's obviously a deep intent to support wearable devices, and those things are becoming higher and higher resolution to the point where, with ODG's glasses, with other partners, we're seeing, the pixel density is going to be huge by next year. The glasses are shrinking, and the stream and the bandwidth is pretty much the same. So light fields do help solve that problem, and a lot of the work that we're doing is designed to democratize, the ability to capture, to render, to process, edit, and then finally publish these kinds of holographic experiences. And when we say something's a hologram, we basically technically think of it as an 8D light field, which means you can also relight it, plus you have other information such as depth, such as normal material properties. Embedding that into a piece of content, whether it's in the capture or playback side, very important. As a company, we productize 3 different tool sets and services around capture, rendering, and streaming. I'm going to start with capture and give you guys an overview of some of the new pieces that we're adding to our cloud service. So the first is a partnership with Facebook around capturing full 6-stop. So this means that, in this environment here, you're seeing about 50 meters from one camera lens that you can now bring into your cinematic workflow and look around from any angle. So based on the slides you guys were seeing before, this would be a full 6-stop experience. We're actually building a lot of really cool pieces with Facebook on the cloud service side. So the cameras that they're providing, including Unreal Engine and of course all the Autodesk tools that support the ingestion of these point clouds. And going beyond capturing just 6-stop environments, we want to support full BRDF capture, full material capture. And to that end, we've been doing that with Lightstage for many years. This is our work on Star Wars, capturing the skin for Grand Moff Tarkin. And we've also been recently partnering with game engine companies such as Unreal Engine, which just recently announced a data set based on our Lightstage capture system. And we see that becoming more and more of a workflow in real-time tools. So when I was describing sort of what 8D video looks like, it really is capturing not just the 6-stop position data, but also the relighting. So this is basically a relightable stream, and you can see that the fisheye in the bottom right is lighting that video. We've actually been improving Lightstage year by year. This is a high-quality capture that you can see. It captures normals and position data for things like eyelashes, super fine-grained details. Very, very expensive camera rate, so we got that down to off-the-shelf consumer cameras, which is what you're seeing here, same exact quality. And with the tools that we've been building, you can then bring that into game engines like Unity or Unreal, and you can relight it, and it just is treated like any other game asset. Fundamental, I think, to the workflows that we're looking at, where you see this convergence of video game engines and traditional tools. And then finally, going back to some of our other work with camera partners like Facebook and others, we want to take any sort of arrangement of planoptic lenses and give you back essentially a light field bubble, like the ones you're seeing here. And the Facebook video cameras, if you just move them through a circle for a few seconds, will give you something exactly like this, where you have refractions and reflections. All the material properties are essentially accounted for or can be computed from that data set. In the tool side of things, rendering is super important. I mean, if you don't have the ability to relight, physically re-render the scene, you're missing a fundamental aspect of the toolchain. So to democratize that part of the pipeline, we partnered with Unity, and our Octane Render system, which is a GPU path tracer, is physically correct. It's going to be bundled for free, and 7 million Unity developers are going to get that tool with lightfield workflows rendering tools built into that. Powerful render. This is the opening of Westworld done in our Cinema 4D Octane plugin by just a few artists. They're obviously very talented, but being able to take this kind of quality and bring that into Unity and mix that with 6-stop and light field video captures, I think is, this is a this year solution that we want to provide so that people can start to really think about publishing and streaming this kind of content in the years to come. And you can see here in Unity, these Orbex assets are now built into Unity 2017. So mixing and matching any of these types of assets is as trivial as drag and drop. And I think that with Unity, we're covering a lot of users that are targeting AR and VR. And the last bit I want to focus on is how do you publish all of this once you're done creating it? So to that end, we've been open sourcing Orbex Media Player. We've shared the source code to the player with Samsung, with Oculus, with others. And what it does is it allows you to take any of the workflows that we just showed you and flatten that down into a very simple light field-like stream. And this is a portal, so this is something you could, for example, drop in a web page. With eye tracking, you could see into that portal, and you get a really high-quality 6-stop window, which is on the list that was shown earlier. Going beyond that, we want to support spatial light field output. So this basically is giving you a volume of space, not just a portal that you can walk through. And the step beyond that is to give you a full temporal world line. So this is actually streaming essentially a 100-meter light field street. There's animation in there. The trees are moving. The car there's a car in there as well that you might be able to see. And the idea is that this is all something that's as simple as baking inside of a game engine like Unity. In fact, one of the things that we've been very focused on is once you have this data rendered, how does it get consumed? So we've been building web players that allow you to run this on a regular phone with a marker or a tracker. The quality improves significantly the better the tracker is, but the streams that you're seeing here are only 1.5 megabits. The source streams on the server are probably closer to about 50 megabytes a second, And that's why we sort of built these sort of two levels. So we can, this is showing Project Tango, we're streaming down depth as well as transparency, markerless tracking. The best quality we've seen is with the help of John Carmack on the Gear VR, we get predictive tracking. This is using a lighthouse to augment the position tracking data, but this looks as good in the Gear VR over LTE as it does when we plugged in a Vive or a Rift into a PC and ran our Lightfield viewer locally. Finally, and this is something we haven't shown publicly, this is the Lightfield viewer, the whole system running inside of Unity Editor. So you can see, you can treat these Lightfields as if they were just a simple quad. In fact, they are. You can create different shapes. And the Lightfield baking system will take your high-quality Octane scenes, bake it back into a Lightfield, you bring it back into Unity, and when you're done, you can publish your Unity and Lightfield packaged experience to the open web. Very important for us. We want to support all these different endpoints, have it just be a link. And to that end, we have support from Samsung. Samsung Internet Browser, which is one of the most popular, I think it is the most popular application on the Gear VR, now supports .orbx ingestion above and beyond what we can do in JavaScript. And you can actually embed your Unity experience, and this is running inside the local .orbx cache file, inside of the experience. So you have everything. You can do the same thing with Unreal Engine as well. And between all these different pieces, we feel we have enough there to probably contribute something significant to these open source formats that are emerging. As I mentioned earlier, there's JPEG Plano and there's MPEG-I, which is focused on light fields. And we think that some of the open source pieces that we've already built could be very useful for this, for these forward-looking workflows. So that's it. Hopefully I got it in under 10 minutes. So, great.
Maybe from last year, so at last year he was working for Lightro. Now he has set up a new own company called Lightfield Labs, and yeah, we have a little bit changed the more computers. Yeah, you know, all of these presentations are very confidential, so we cannot share this. At least we show it to you. That's important, and I think it's very exciting what he will show us. And if he's ready, then we can start. Okay.
Okay.
Speak and
Testing. There we go. Now we're back on. All right. It is a pleasure to be back. I'm really excited to announce this month the debut of a new company, Lightfield Lab. Our mission at the company is to be completely focused and dedicated not only to the capture side, but now everything that happens after you acquire any content. So to that end, we have a vision to bring this into the consumer entertainment experience. We're going to be starting off building these prototypes. We'll be sharing quite a bit of that information later this week as well. But there are 4 key components that we are specifically targeting. And when you look at all the work that the rest of this panel is doing, and I always think I can't be more blown away by the Otoy demonstrations, and that stuff's really impressive, super impressive. But that is really seeing the entire ecosystem really truly start to come together to enable holographic media to become something that you can bring to the home and make it practical. It is something that science fiction has promised me that I would have, and I want my hologram in the home. So we're doing that. So you have the display. We're working towards those technologies. We have some very novel approaches to make that not only possible, but make it something that is able to be scaled and a very thin panel, as well as be able to fit into an appropriate cost point. Then you also have the format. You're seeing a lot of work that's happening with all the standardization committees, and that is key to ensuring that you have a viable method to take all of that content and stream it to the actual end user. If you don't have a methodology to do that, you're going to be very challenged to have a full and adopted ecosystem. And part of that then requires an API to allow everybody to take a holographic display, the holographic content, and then integrate it directly into a device, integrate it into your content and the workflow as well. And then finally, the longest term part of this mission is to integrate directly the idea of full interactivity for all Lightfield holographic content. So it's not only the ability to move around spatially, it's also to be able to have the full sensory experience, including having the ability to touch and feel objects. And that's something that is a very long tentpole item for us, and we are making sure that all of the architectures, all the APIs that we have, integrate that directly into the structure. So I have a quick shameless plug because this is only a 10-minute panel. We also have the big super session that is on Tuesday. I'll be diving much deeper into the product and the actual technology rollout, in addition to a bunch of the business concepts as well for display mean. So you see a lot of things that are happening in the VR and the AR space right now, and when you really think about it, VR and AR is a great approach to really help scale down the amount of data that has to be put onto a physical holographic display. So it's something we call motion-induced light field. But when we're talking about a true holographic display, it means that every single ray is completely distributed, so when you're looking at it, you see that object in true XYZ space floating as a point right in front of you or inside of the screen as well. So the way that this actually works is the fact that when we see an object, we don't actually see the physical object. What we're seeing is the light that is actually reflected off of those surfaces. And you're hearing things about these different properties and different material samples, and that is fundamentally what is required in order to understand how all of that integrates. So with the light field display, imagine then taking that actual physical object, making it into these many millions of these microscopic pieces and segments that project the light into very explicit coordinates. And with that, what you can do is take that density and put it directly into space, so you have truly holographic and free-floating media. So that is a very high-level understanding of how the technology works. We'll go much deeper on Tuesday, but for today what we want to focus on is when you have this kind of content, what are the implications for how you generate it, how you stream it, and how you produce it. And I'm going to show you through this simulation that we have. It is all true samples from a synthetic scene. That synthetic scene allowed us to get infinite density to show off what a true reference design looks like and go all the way through to having standard just 2D elements and wanting to project that into a holographic experience. So with that, there are a number of considerations that are very important to understand when you're really looking at how you build one of these displays. Holographic display, it's also important when you look at the AR/VR space. You have how many rays per degree that you have. That's your sampling density. You need to understand how large is that volume, how far can you move within the space, and finally, what is your effective 2D resolution at any given slice in the scene. And all that boils into what is the effective density and resolution that you need to create that compelling light field holographic experience. If you really break this down, you get into something that is clearly in the many gigapixels of rays that you need to project to have the ability to both fuse and focus at an object. So you're not focusing on a screen plane, you're actually focusing on a point directly in space. So, you've seen a couple of the other examples here. There are three key things that are required in order to produce that interactive or the free viewpoint experience from a light field. You need to have your image data for some number of viewpoints. If you don't have that, well, you're not really looking at much. Relative world coordinate for every single point in space, and that is how you correlate the entire system together. And finally, you need to have the world coordinate of the new viewpoint. And that is specific if you're doing any kind of head tracking, but really what it is to highlight if you are seeing this demonstration, you have all of those many viewpoints from the light field sampling, and then you have a free viewpoint to see exactly what it would look like if you have it in the headset, or if you are physically moving around an actual display and seeing the final render result that your eye is able to view. So we've broken that down into these four categories for defining the metrics. And the metrics are a bit of a relative quality from one approach to another. And you feel free to make your own judgment calls. These are just how we look at it. This is helping us inform how we build the actual underlying imaging approach. But what you see here is that you have the first category of the light field sample quality. What that means is, how many true samples do you have? What the actual material, the actual object is in space, how you see these rays moving as you do the viewpoint interpolation. You then have this next category of the infrastructure impact. And this includes everything that has to go into the challenge of producing the material. And that also includes anything that's involved with administrative data handling and also the artistry involved in producing that media. You finally have the display hardware requirements, and we've lumped that into any processing, any transmission, anything at all that has to be done on the display end or on the real-time processing end, including things like gaming engines. That is then one of the other metrics. And finally, it is what is the emotional experience that you have from the actual content, from the display itself. That is what we're calling the light field experience itself, and that's what is so key to enabling the ability to have this as a full sensory experience. So here is our first example. Let's see if I get my little laser pointer out. This is the very dense array of 137 radial distributions from a light field array. Now, it is a synthetic sampling, so that way we know we have everything perfect. We can then distill that into all the following samples. But the things that are really important to note here is the sample quality is what we consider the highest. It's a scale of 1 to 4, 4 being the absolute best, it's perfect, it's ground truth. And then you have on the bottom of the scale, on a 1 is either the most challenging or the most limited. So clearly, if you have a data set that requires that many fundamental independent samples, that many rays of light, trying to get that to your ultimate end display and transmit that data has a huge impact on the infrastructure, has a huge impact on the ability to display that because you have just such massive bandwidth. But at the end of the day, the light field experience is as if it is a true object in space. And we want to see through these demonstrations, how far can we push that boundary with the most limited amount of the data that you have to take, specifically get to the end display. So just to show off some of the things to look for through the rest of the demonstration, look at the true reflection, refraction that's going on in this. You see as we're moving this free viewpoint, and again, the array itself, the fundamental underlying capture of this is completely static. Everything in all of these configurations is a static array, and the only thing that's actually moving here is that free viewpoint virtual camera, that is the position in space. Again, to represent either you with a headset or you moving around a full true holographic panel. So you see this is one of those key areas. Look at the edge detail, the fidelity, look at the accuracy of everything in the scene in terms of how you're actually able to then, I'm doing a time check, wow, I gotta go fast. Sorry everybody, we're gonna go real quick now. But look at the imaging quality of this. We're gonna go to the next example quickly here, where you see this is a 3 degree of freedom. You're all familiar with this. You put your headset on, you're inside of a bubble, you don't have any parallax, and we're hoping that it becomes really clear that you have lost all light field. A VR stitched image is not a light field. It has been reduced to a singular viewpoint, and all you're doing is then pan and scanning through the image. You then also have, obviously, the opportunity to have a real-time gaming engine. And that gaming engine allows you to have access to all of the potential light field samples, depending on the actual engine itself. You do get the transparency reflections, but you get into this uncanny valley. You have limitations on what you're able to render. This has a poly count that is less than 1/10 of what it was able to do from either a photographic or a true ray trace sampling that you're seeing in the other examples. But you do have a relatively high quality of volumetric experience from this type of an engine. Then we're going to get into something that I'm going to apologize for putting on the screen, but I'm going to do it. So this is going back to the days of 2D to 3D conversion processing. This is an automated technology. This is a true, real commercial tool. I won't say who. Let's all promise that we are not going to do this. That this is what you would get for any disparity estimation from a single viewpoint. It looks like jelly vision, but because we're actually trying to move the camera virtually so far apart and such high degrees of inaccuracy, you end up getting this artifacting, stretching, and warping, but you will see this in any disparity estimation to a lesser degree, but it is a really important note that all disparity estimation has internal estimation, which results in having inaccuracy to some order of magnitude. Then we get into a potentially more interesting approach where you're getting into, this is just a 2D layered image. You have a backplate and you have your foreground element. There is no texture information outside of the single sample. You'll see that when this goes in front of the mask, you'll see no actual ability to do the reflection refraction, but it is an almost interesting, compelling experience, even though it is a single 2D image. So this is just showing off, even though you're not getting any light field, you do get some amount of a volumetric experience. You obviously are missing all the occlusion information for things that go beyond the frame, and you do have quite a significant number of edge artifacts, but it is just another way to look at the ecosystem that you can take and repurpose all 2D content and still get a compelling experience. So here what you're seeing is a horizontal array of light field samples. You do get quite a bit of that information in terms of the true reflections and that true volumetric space back to that density point. But you'll see things going in and out of these pockets where you're flashing in and out. You get artifacts, a lot of edge detail problems. But then you go into now the proposal here that we have for this. It's a hybrid sparse array using and leveraging real-time processing on top of the existing content itself to just show this very quickly. You're able to see the true reflections, refractions. I would challenge you to see any visual difference between this content and then that dense imaging sample that you just saw a moment ago, where you see the reflections, refractions all performed by the surface IDs and the material sampling. And what you're able to do here is then regenerate the full light field using the high quality RGB imaging data from a 24 sparse radial array. And then from that, you can then distill the full volumetric experience. You've already seen this. This is just a throwback to the original image that you just saw a moment ago that had the full high density, just to give you a visual reference back to that point. And then finally, as I race through this to the end, please come on Tuesday so I can give you a lot more detail. But the summary here is make sure you understand all the technologies for light field display so you know the pros, the cons, the trade-offs, know what is light field, what is not, so you can fully understand what the content, what your project needs are. Then understand what are the benefits of how you produce, how you generate the content. And then finally, let's all work as an industry here to work towards this holographic future. And I'm really excited to work with everybody else that's on this panel and bring holographic display to the home. So thank you again. I thank everybody else as a special, oh, I preempted everybody. I apologize. One more time. This is everybody that helped out. Ellery, the fantastic artist here, huge amount of work. And then we got Steve, my lovely wife, who actually allows me to do this crazy stuff. And then the rest of the team here. So now, thank you, everybody. Really.
One of the questions we're asked all the time is, what is virtual production? And at Stargate over the last 15 years or so, we've developed a number of tools and techniques which greatly assist filmmakers to achieve their creative ambitions on a budget. One of the most important tools in virtual production is our virtual backlog. The Stargate Virtual Backlog is a very unique collection of locations, both photographic and virtual. Computer-generated props, cars, set extensions, everything you need to blend a virtual location with live-action cinematography.
It used to be that we would shoot split screen and set extensions, and then in post, we would build the environment. With using the Stargate Virtual Backlog, that 3D environment, or that 360 environment, is now seen by everybody up front.
The Virtual Backlog has developed over a number of productions in many years, from historical dramas to futurism and fantasy.
First things we learned was there were really no limitations in the virtual world. You can put together a world and make it 100% immersive. But virtual production, pre-production is extremely important.
So you really look at a script and say, should we be doing this for real or should we be doing this virtually?
Our involvement early on is critical.
When you have the environment already built, it allows the writers to better understand what they can write to. It allows the lighting and the production design to understand what they need to build.
Thank you very much. So I think we need also some time for the panel discussion. So my first question goes to Al. So if we are seeing this productions, how much of the content will be computer generated and how much is real, or how much effort is really necessary to bring all of these different real images together with the computer generated images?
Well, I would say definitely there has been a rise in demand for visual effects with a lot of 3D in it, to the point where we've actually now switched over to cloud rendering to support what we have internally for internal rendering. But it's the process of building these virtual sets, like the ones you saw on the video, is a time-consuming process, and that's kind of what I was referring to earlier when I was speaking, that we need to find a faster, more efficient way to generate these environments, to be able to do this on the time and budgets that we're allowed in television and film production.
Okay, so maybe to all of the other questions, do you think that in the future we can really merge all of the real captured images and work in the same way like the computer generated images? So what's your
I think absolutely. I mean, that's what we're trying to do as a company. And there's a lot of big steps that have come online this year. The Facebook 6.0 capture system is really good. And on top of that, if we add BRDF capture to that, you have a workflow that I think, if you're already working in the cloud, is going to make this thing seamless. I mean, the goal that I think you want is you want to have it so that you can run Unity or Unreal real-time on set, bring those assets in, and basically have it all done live. Maybe next year, but it's going to start this year. So I think it's totally doable, and it's happening now.
Okay. Yeah, I mean, I think you're already seeing that full integration starting to happen, especially with all the virtual backlot, with the light stage, everything else that's happening. And it's just now getting to that photorealistic nature in order to bring it to the next level. So there's a lot of that work that's really, really compelling. And I think eventually you're going to start seeing that merger happening as more as that industry standard rather than as the cutting edge.
So what do you think is the most important new feature of the light field? Do you think it can be used to make more special effects, or at the end allows more degrees of freedom to the viewers itself?
So right now, because of the limitation of the types of displays that are available, the ability to extrapolate and have all of the great things that Lytro is able to do with the light field to produce different visual effects and have that much more information is really a great way to leverage light field data. But as you start to move forward and you have true holographic display, you're going to see that now you're able to take every ray that you had, and instead of throwing them out and distilling into a 2D slice, you're able to leverage and show them all simultaneously. So I think it is going to start evolve all towards this free viewpoint integration process of the holographic image, where today you're seeing the ability to leverage that for the standard visual effects optimizations for everything you can do with content and media.
I would add that essentially the sort of a holographic digital negative that you capture with light field light camera or volumetric experience is great for preserving and archiving what you're shooting, because you may find that as true light field displays, which is awesome by the way, coming to market are going to be game changers. Like, you will want to see the content that you shot 5 years ago, work on that. And similarly, one thing that is interesting is I didn't expect light field displays to come to market this quickly, but I was looking at wearables and HMDs with, essentially giving us slices in real time into those kinds of holographic experiences. So you're going to have both of these at the same time, and I think that our vision is just that we get these tools and the cameras themselves to be democratized, and we're all working towards that. But I think it is going to start to happen this year and next.
I mean, I have a question for you guys. How long before I can get rid of green screen?
We'll have to go, there's a bunch of the Lytro team here as well.
I'll speak for the Facebook stuff, because basically that one of the ways that they pitched it at F8 was that, well, at the very least, you can get rid of the green screen, because you can essentially take the depth from those cameras, and it's super simple, and you just create a master map. And they can do more computation on the cloud side, which is where I think there's a lot more things they can do. And they can do object segmentation, all the deep learning stuff Facebook's doing around images could be applied to do that even further. But absolutely, getting rid of green screens is definitely something you can do with those existing cameras. Those are shipping Q3 or Q4 this year.
Okay, but I'm still a little bit skeptic. We are working also on light field for many, many years, and the question I think is, and what is most important for you, Al, is when is it cheaper to using light field instead of a green screen?
That's a good question. Are you looking at me? I mean, so Facebook hasn't announced the price of the cameras, but the fact that one of them is just this little 6-lens system, I think is going to make it, it's meant for prosumers, so it's not even meant for super high-end productions. To whatever, so I think that as I said, probably next year is where you're going to, I would say it would be next year.
Well, I mean, cost and accuracy, right? I mean, how accurate are those masks going to be so we can actually have hair detail?
Sure. I mean, just to answer Siegfried's question first, I think the main thing to understand about light field technologies is that it can't be the only driver and desire to have green screen removal. It has to be about the creative impact, all the things that you can't do with a traditional camera. If that isn't the main driving force, then of course you do have that cost challenge. So anyway, I just wanted to make sure we address that aspect.
Yeah, I just looked at it as one of the early steps of adopting this technology.
Yeah, of course.
Viewpoint reprojection after shooting, if you're looking at publishing to autostereoscopic light field displays, HMDs, which do matter, which are growing in quantity, then it does make sense to sort of invest in there. I think if you're trying to totally replace your simple 2D workflows with higher-end camera systems, as I said, maybe next year you'll see the cost drop to the point where it might be trivial to do that. Things like hair are hard. However, as you guys have seen from the Lightro stuff in the past, it can do that really well. So I think it's all doable.
Okay. Saying next year is for sure for some first pilot experiences. When do you think will lightfield be a regular process in the content production?
I would say 5 years, 4 or 5 years. When we say regular, it means it's everywhere, it's ubiquitous. I would say 4 or 5 years, maybe, that's my guess. It'll take, we have a sort of a ramp up where there are a lot of people that still don't understand what it is, how it could be used, what the examples are. And I think that ramp up to, towards those 5 years is when you start seeing the inability of you to publish content on millions and tens of millions of displays of light field screens. Like, you're not going to not look into this workflow and not consider it seriously. And I look to the VR space where almost every single DCC tool out there has some sort of VR rendering capability, just because of, frankly, Oculus and the Rift and all the stuff that started a few years back. So I think light fields are 3 or 4 years from now will be in that same place, because whether it's AR light field displays, there's going to be so many places where your content just won't be experienced correctly without this kind of workflow. And it'll be a lot like color or sound before that, in my opinion.
Yeah, I totally support that. I think it's when you start seeing the more ubiquitous nature of all of the light field enabled types of technologies for display, that you then have a challenge of you have no other methodology to create the content unless it's completely virtual. So once you have that much larger mass adoption, and that is the vision for what we are attempting to achieve, that we would be putting that many of these light field displays out there, and then that's when you have to capture it as a light field or render it as a light field. So that horizon, I think you're in that ballpark when you're looking at that 5-year type horizon, when you're going to have some quantity of these units and some log of the number of the physical user base, especially in the larger venue type attractions, and especially with all the VR, all the AR things that are coming out. That's when you're going to see more of this culmination and the requirement to shoot with light field. And then you look 10 years out, I think that it's going to be just an industry standard.
Okay. So that means, in principle, we would probably see a kind of evolution where we see light field first, let's say for some special effects, then for some VR glasses or HMT, and then for light field displays. And
well, I have a very sort of practical view, which is I think you're going to see it used in game engines, because that's what we're targeting first and foremost. So you don't have to, you can bake light fields to replace complex rendering effects. And then secondly, I think that there's one thing I forgot to mention, which is you look at what Facebook announced with the AR stuff, there's a force function that's going to happen when you have eye tracking on your phones and you can look into that little 6-dot window that you had on your list. That's going to be huge. That's going to be bigger than almost anything else to drive that almost immediately. And we haven't gone there yet. This year will be a good harbinger to see how far that goes, but I think that's another major thing that will drive people to this workflow.
okay. So now we will allow also some questions from the audience. So if you have some questions, please stand up and ask the panelists. Or is everything clear? Everything? The future is...
I would like to know, for example, using the light field capability, if in driving for VFX, for example, knowing that we want to try to achieve another way of transmit and produce content, getting an environment completely in 3D, how would we say that to be far, for example, okay, I can get this, but I have different materials like plastic, like metal or other stuff that reacts different to the light. So if I want to put this inside one of production that I mix live and this kind of thing that I capture, do you guys have some plans to deal with this kind of thing? I mean, does light field deliver me the way that is being captured measures that I could extrapolate to material reflectance, for example?
So I think the easy answer is if you look at the light stage, it does that and more. If you're trying to do that in a real-world environment, there are some scanning technologies that can be leveraged. And then at the end of the day, I've seen some really fantastic examples where you manually identify the object on the surface. And if you do that, you can then directly integrate into any of those interactive engines and get the true sampling that you want to ray trace in the composited environment. But today, in order to have any automated solution for that in a live action environment that is a uncontrolled live action environment, it's very challenging. But if you go to the light stage, you have all of that and then some.
And if you don't have the light stage, just to your point, it's actually to John's point, I mean, when you're talking, you're sort of that lightweight, you're talking about materiality, probably embedding the IR in there. One thing we did discover is even with simple 6-stuff capture, if you have good object segmentation, you almost have a mask for each material or object. You can then, put in an IR or add a material to that. That works really well. So that is an alternative to bringing the full light stage data set there, and it's exactly the point that John was making. That, to me, is the cheapest, most efficient way of doing it.
You'd say that deep learning segmentation would be an option for this?
Yes.
Thank you.
Okay, so last question and then we have to end, please.
What keeps light field from going the way of 3D, where it's primarily seen in theaters as kind of an added value experience, as opposed to revolutionizing or just completely changing the way that color, HD, 4K, and now HDR is doing?
Sure. I mean, I think that 3D was a gimmick, whereas light fields are a fundamental property of the real world. I mean, it gives you 3D. It gives you, in a sense, much higher fidelity. I mean, it's closer to the concept of adding a dimension of experience that isn't a gimmick. And I think that it's also, I mean, more importantly, it's really necessary in workflows. I mean, whether you're targeting 3D or VR, you're going to need to capture more rays. You're going to have to understand what that object looks like, even to just get out a 2D scene. So I just think that 3D was pushed in the wrong direction, especially in the home. You're not going to have that effect with light fields. And you can look at things that are moving pretty well, like VR and mixed reality. Those things are huge. No one's doubting that's going to turn into 3D. It's not. Light fields are in that same category, in my opinion.
Yeah, and just to dovetail off of that, when you look at the transition from all the different types of media you're just referring to with HDR and color, it is a way to accurately reflect what we actually see. And when you look at stereo media, because you are putting both something physically on the body and you are also then creating the illusion of depth, it isn't actually something that is biologically allowing your eye to fuse and see the object. That's getting a little bit more into the biological.
So unfortunately we have to stop, so I have to see the answer. Very